All right, this is 4.5 homework. So we're going to deal with the other trig functions. We did sine and cosine, so now we'll do tangent and cotangent. We'll also do cosecant and secant. So this first one is tangent. It wants us to write an equation for it. We know it's tangent based on the shape, right? Tangent looks like this. Cotangent is going to be the other way. But we don't know the period of this thing yet. So let's take a look here. It looks like it repeats every 1. This is halfway in between 2, so that'd be 1. So the period is 1. Now the period of tangent we know, and this is on our formula sheet as well. The period is pi over b. So we know that 1 has to equal pi over b. So that means if you multiply both sides by b, b equals pi. And so when we go to write our tangent equation, we have a times the tangent of bx plus c plus b, just like we did the sine and cosine. This thing's not shifted up or down at all, so there's no d. The vertical stretch of this thing is really hard to tell, you know. So always just try 1 here, and if that doesn't work, then, you know, it's going to have to be 1, because otherwise they have to give us an ordered pair here so we can actually find out how much it's vertically stretched. So that's probably only going to be 1 for this homework. We know b is pi, so this turns into pi x. And then you can look and see if it's shifted at all right or left. And the easy way to check that is think about the unit circle and what tangent is. At this point, you know, this is the order pair 1 comma 0. So keep in mind that tangent is sine over cosine. So at this point you have 0 over 1, which is 0. So at 0, the tangent is 0. So at 0, the tangent is 0. Just check that out, and it is. So therefore it hasn't been shifted to the right or the left at all. So basically there is no shift here, so my answer is tangent of pi x. Our next problem is just a one that we can practice our transformations of functions. So we have tangent of x. It's vertically stretched by a factor of 6, so we know that that's the same as dividing y by a number bigger than 1 on our formula sheet, or multiplying, you know, the other side by 6. So you have 6 tangent of x, and then it's vertically stretched by a factor of 6, which we got shifted a distance of 5 units to the left, so the x plus 5. And translated 4 units downward would be minus 4 outside in parentheses. So there's our function. They used f of x for this. And just enter this in. The next problem says enter true or false depending on whether the statement is true or false. So sine is odd and cosine is even. That's true. That's in our book. You can find that information on the web. But keep in mind that on the formula sheet I gave you some hints there too. Here's an even property for an even function, and here's the property for an odd function. So you can kind of look at this. You can actually get this from the unit circle if you want. We know that if sine's odd, then the sine of negative x has to equal the opposite of the sine of x. So if you do negative x right here and positive x right here, then the sine of negative x should be exactly the same as the sine of positive x, only opposite in sign. And it is. So say that this sine is the y value, say that's 1/2. This is negative 1/2. So it is opposite in value, which is exactly what this says. The sine of the negative angle is exactly the same as the sine of the positive angle up here. You just put a negative sign on it. It's a little hard to reason through, but that's how you can do it from the graph. And cosine is even similarly, because, you know, on the unit circle, if you have a negative x and a positive x, the cosine values are the x values, which are the same. I didn't draw that very well. But the cosine is the same for here. So say the cosine is square root of 3 over 2 here. It's the same for both positive and negative, and that's what the even says. It says that the cosine of negative x is the same as the cosine of x for the y values. Okay, next one, tangent, or the range of tangent is all real numbers. That's true. We just looked at a graph of that, and it's not hard to see that you can get all y's out of it for whatever angle you put in. So that's true. Next one, tangent of 2x has a period of pi. Well, we know that the period of tangent is pi over b. In this case, our b is 2, so we'd have pi over 2 for the period, not pi. So that's false. Tangent and cotangent are odd functions. These are a little harder. That turned out to be true, and like I said, that information is available on, you know, in the book or on the web. But you can reason through it again. It's a little tricky this time because say this is x and say this is negative x. I'll just do a value for this. So say this is square root of 3 over 2 for cosine and 1/2 for sine. This would be square root of 3 over 2 for cosine and negative 1/2. So I'll pick 30 degrees and negative 30 degrees. Well, you can see that if it's odd, then the tangent of a negative x has to equal the negative of the tangent of the positive x. the opposite of tangent of positive x. So tangent of negative x here is opposite over is negative 1/2 over square root of 3 over 2, sine over cosine. And then this would be negative the tangent, and the tangent here of positive x would be opposite over adjacent, or sine over cosine, which is 1/2 over square root of 3 over 2. So that checks out. I know that's only one example, and this has to be true for all angles, not just 30 and negative 30. But, it's an easy way to check, just to, see if it is odd or even. So those are right in your formula sheet right here, so definitely know how to use those. Okay, the cotangent is just the reciprocal of tangent, and it ends up having the same period then. So we know the period of cotangent is the same as tangent, which is pi over b. In this case, it's pi over, and then b is 8 pi over 9. Instead of dividing by a fraction, I'm going to multiply by the reciprocal, so I'm going to multiply by 9 over 8 pi. The pi's cancel, and I get 9 over 8 from my period. Okay, the next problem gives us this function here, tangent. It's been transformed, and we want to know the new period and the phase shift. So the period of tangent is always pi over b, which in this case is pi over 9. That's pretty easy. B is 9. The shift is a little harder because I'm going to factor out a 9, so I'm going to make this tangent of 9 times x plus 2 over 9. So it's kind of tricky to factor out a 9 because there's not really a 9 as a factor of this, but if you pull it out, then obviously 9 must be in the bottom, so that when you distribute, you get 2 back. And the reason why is because then you can isolate what you're doing to x in parentheses. What you're actually doing to x is you're adding 2 over 9, which moves it to the right 2 over 9. So I'm going to do, moves it to the left 2 over 9. So I'm going to make the phase shift negative 2 over 9. And it says use negative for shift to the left. All right, next problem gives us secant. Secant is the reciprocal of cosine. And we know the period of cosine is 2 pi, so therefore we know the period for secant is also 2 pi over b. So in this case we have 2 pi over b, which is 5 pi over 3. And I'm going to multiply by the reciprocal instead of divide. So I'm going to multiply by 3 over 5 pi. Pi's cancel, and you get 6 over 5. Okay, the next one wants to know which functions are even and odd. So this is a little tricky, but I'll take the first function, for example. F of x equals sine of x over x. Now we know that if it's odd, then it has the property, or if it's even, it has the property of f of negative x equals f of x. So if we stick in a negative x in for x here, we should get the original function back. So let's try that. F of negative x equals sine of negative x over negative x. Now, we know that the sine is odd, which has the property of the sine of negative x equals negative the sine of x, so I can simplify that by pulling the negative out, basically. And then that negative cancels with the negative in the bottom, and you end up getting back the original function, which is exactly what an even function does. When you plug in negative x, you get the original function back, which is exactly what happened. We plugged in negative x, we got the original function back. So that's an example of an even function then. All right, the next one. We know the function is f of x equals 2 sine of x cosine of x. Well, if it's even, keep in mind that we need this to happen. F of negative x has to equal f of x. So f of negative x in this case gives us 2 sine of negative x cosine of negative x. Now we know that this simplifies because we can pull the sign out of the sign, the negative sign out of the sign because it's odd, so it turns into, I'll pull that negative out front. And then cosine is even, so the cosine of negative x is cosine of x. So this ends up being the opposite sign value when we stick in negative x, so actually this is odd, not even. So we're not going to check that one. Cosine of 2x, we know cosine of x is even, so cosine of 2x is going to be even as well. Multiplying 2 right there doesn't do anything. So that's going to also be even. Sine's odd, sine of 2x is still going to be odd. Tangent's odd, so moving it up 2 units still keeps it odd. And then the last one's a tricky one. F of x equals cosecant is really 1 over sine of x squared. So when I plug in negative x, that turns into 1 over sine of negative x squared. Now, when you square negative x, you just get x squared. So this really simplifies to sine of x squared. Well, which is the original function, right? So when you plug in f of a negative x, you get the same thing back, which is cosecant of x squared, because squaring a negative gets rid of it. So this one is even. So just a reminder then, sine is odd, cosine is even, and tangent is odd. Okay, so then you can do this with numbers too. So if the tangent of x is 0, then tangent of negative x is negative 0, which is just 0. Same thing here, the sine of x is 0.9, then sine of negative x has to be negative 0.9, right? Because it's odd, we change the value of the y sign, right? That's right on our formula sheet. F of negative x is equal to the opposite of the original, f of x. So just change the sign. Cosine's even, so cosine of x is 0.3, then cosine of negative x is still 0.3, because f of negative x equals f of x for that one. So then tangent of x is negative 0.5, then tangent of pi plus x is the same thing, because the period of tangent is pi, so it repeats every pi. So if we add any increment of pi here, we're going to get the same value back, that we had for just tangent of x. All right, I hope this helps.